Welcome to the video for 8.3 variable acceleration in 2 dimensions. In the previous video 8.2 we looked at constant acceleration, and in constant acceleration we can obviously use the Suvat equations. We cannot if the acceleration is variable. Okay, so generally you're going to get given some sort of formula for either acceleration, displacement or velocity. What we've got to remember is that from year 1 that the differential of displacement is equal to velocity, and the differential of velocity is equal to acceleration. So the second differential of displacement is equal to acceleration, and then obviously it works the other way around. The integral of velocity is displacement, and the integral of acceleration is velocity. Okay, so now we can put, let's attack these questions. Okay, so in this question we've given an equation for acceleration. And we're told that time equals 0, the velocity is 1 over 2 pi. We need to find an expression for velocity. So velocity is equal to the integral of acceleration, so the integral of cos 2 pi t with respect to t. So that will give us, right, so it's going to be 1 over 2 pi. I'm assuming by now you can do all this integration and differentiation from the work that you've done in pure. Flips to sine of 2 pi t plus a constant with respect to, I don't need to write that in now. So then we can write time equals 0, velocity equals 1 over 2 pi. 1 over 2 pi is equal to 1 over 2 pi. Time is 0. The sine of 0 is equal to 0 plus c. That means c must be equal to 1 over 2 pi. So writing out that equation in full, 1 over 2 pi sine of 2 pi t plus 1 over 2 pi. Okay, that's part A. Part B says find the maximum speed. Okay, so let's think about what this graph is going to look like. It's going to be a graph sine wave, and as we know, the max of sine x is equal to 1. Okay, so the maximum for this part here is going to be equal to 1. So we can put that in. So the max velocity is going to be 1 over 2 pi times by 1 plus 1 over 2 pi. 1 over 2 pi plus 1 over 2 pi, 2 over 2 pi, which would be 1 over pi meters per second. That's the maximum velocity, part B. Part C. Part C wants us to find the distance, so displacement, and we know that S is the integral of velocity, so the integral of this equation here, 1 over 2 pi sine 2 pi t plus 1 over 2 pi with respect to t. Okay, so I can make this easier by factorizing out the 1 over 2 pi. And I'm doing it between 3 and 0. So this will be sine 2 pi t plus 1 with respect to t. Okay, so let's integrate that now. So integrating that, reverse the sign. Cos 2 pi t plus t between 3 and 0. Substituting the numbers. So 3 first. So if I substitute 3 in for t here, we're going to have 6 pi. So it's minus a half 2 pi. Now if you think about the graph for cos, get this up and down like that. This being 2 pi and this being 0. So multiples of 2 pi will be equal to 1. So 6 pi is going to be equal to 1 plus 3 minus, substituting in 0, 1 over 2 pi. So 0 cos of 0 equal to 1 also, and plus 0. Okay, so you've got minus 1 over 2 pi minus negative 1 over 2 pi, cancels out. You've got 3 minus 0, 3, so it's 3 over 2 pi, which if you want to write as a decimal is 0.477. Three significant figures. Right, that's example 5 done. Right, let's go on to example 6. A little bit more space here. Can we see the bottom there? There we go. Right, particle mass 6 kilograms is moving on the positive x-axis at time t seconds and displacement s. So this time we've been given a formula for displacement and we want to find the velocity. Okay, so velocity is equal to the differential of displacement. So if we differentiate this times by 3 over 2, which would give me 3 t to the half minus, I'm timesing by minus 2 at the front here. So 2e to the minus 2t all over 3. Okay, so that's the formula for velocity, and I want to find out the velocity when t equals 1.5. T equals 1.5 here. So velocity is equal to 3 times 1.5 to the power of a half minus 2e times minus 3, 2 times 1.5 over 3. Just grab our calculator out and do that. Gives us a value of 3.64 for part A, and that is, what is it, meters per second. 3 significant figures. Okay, right, next one says, given that the particle is acted on by a single force of variable magnitude, which acts in the direction of the positive x direction. Okay, so we want to find out force, and we know that force is equal to mass times acceleration. We have the mass, but we don't have the acceleration. Okay, so part B is a little bit of a problem solving question. In order, you've got to realise that you've got to work out the acceleration. Acceleration is dv dt. So in this case, times by half, so you've got 3 over 2 t to the power of a minus a half. This time we're going to times by minus 2 again, so this time it's going to be plus 4e to the minus 2t all over 3. Okay, we want it when t equals 2. So acceleration is going to be 3 over 2 multiplied by 2 to the power of minus a half e minus 4 over 3. Calculator, just do 1.5 for 3 over 2. 1.09. So 3 significant figures. Meters per second squared. In fact, I'm going to keep it more accurate than that. I'm going to keep this number in my calculator. I'm then going to put it into this formula here. Force is equal to, well, the mass, 6 kilograms, multiplied by, well, it was 1.085. We'll times this by 6, gives us 6.51. Newtons. And there you go.